They're trying to trick us by not giving us a function that is in descending order. That's okay. We are able to do it. And it's okay that you decided to choose a degree 5. It's okay too. It's the same with degree 3. There is no big difference. Okay, so I'll start my table. I will write a domain. As we know, all polynomial functions are defined everywhere. They never give us any problems. Okay, because it's an odd degree, it can only do this or this. The leading coefficient is negative. When the leading coefficient is positive, the function does this. When the leading coefficient is negative, it does this. So it's coming from positive infinity and goes to negative infinity. From positive infinity and goes to negative infinity. Fine. But now I have to find the x and y intercepts and of course the multiplicities. That's basically all I need. I know that when I plug in 0, I get 0. 0 always has to be in the table. Because those polynomial functions will always have a y-intercept. When x is 0, 0, 0, 0, y is 0. So now I have to set this equal to 0 and find the x-intercepts. Degree is 5. So I expect 5 solutions. And I also expect maximum 4 turns. It cannot turn more than 4 times. And it doesn't have to turn 4 times. It may turn only twice. Okay. Because it's degree 3, it cannot turn twice. Oh, you can turn twice, actually, yes. Okay, so I just have y equals 0. So then negative x to the 5th minus x to the 3rd plus 6x equals 0. I refuse to solve any equation with a negative leading coefficient, so I will multiply by negative 1. So x to the 5th plus x to the 3rd minus 6x equals 0. Of course, I will factor out x first. X to the 4th plus x squared minus 6 equals 0. Yes, you can factor or not, or you can plug this in the graphing calculator immediately to find the x-intercepts. I'm fine with that. So in the graphing calculator, I go to apps and 9. I don't need really to put in the whole thing. I just need the degree 4, only because I already have found the solution, it's 0. So for degree 4, the first coefficient is 1. Careful. The second coefficient is 0 because there is no x cubed. The next one, there is x squared, so that this coefficient is also 1. There is no term with x. And the free term, we call it free term, free of x, is 6. And now I expect 4 solutions. I also expect some imaginary solutions, you'll see. Yes, the 1.73i doesn't exist. The negative 1.73i does not exist. So this is the square root of 2 and the square root and negative the square root of 2. So 1.4. So x is 1.4 and x equals negative 1.4. So negative 1.4, 1.4. Notice that all these solutions, x equals 0, x equals 1.4, and x equals negative 1.4, all of them have multiplicity 1. All of them appear once. So it must be a straight cross, either this way or this way. No turn, no slow cross, no slow turn, no. All of these are regular crosses. Cross, cross, cross. Okay. By symmetry, because I have left and right, negative 1.4 and 1.4, you will see that this function is symmetric. If you remember, how do I know this? It's because when I plug in negative x, let's see what happens. I hope you remember f of negative x equals negative f of x. The function is odd, symmetric with respect to the origin. And when f of negative x equals f of x, the function is even, symmetric with respect to the y-axis. Okay, so when I plug in negative x, I get positive x to the fifth, positive x to the third, and negative 6 x. So f of negative x is x to the fifth plus x to the third minus 6x. This changes into positive, this changes into positive, this changes into negative. And this is identical with the opposite of this, negative f of x. So the function is odd. F of x is odd. So again, let's summarize. I started the table by finding the end behavior. How do I know? From the leading coefficient. But if I don't rearrange the function in the correct order, I may not identify the leading coefficient correctly. So I rearranged it. I found the leading coefficient. I know it's odd. I know it has to look like this or like this. And since it's a negative leading coefficient, it comes from positive infinity and goes to negative infinity. Then quickly with a calculator, I found the x and y intercepts. Well, the y-intercept was clear, but I found the x-intercept and the y-intercept, so it goes to the origin. That's one of the reasons why I was thinking that it may be symmetric. In this case, it's odd. And now I'm ready to graph it. Okay, so almost here, negative 1.4, positive 1.4, and 0. And now the table will tell me what to do. It's coming from positive infinity and crosses. These are all crosses. Okay. It has to turn because it crosses again. It must turn. It's symmetric with respect to the origin, so this height has to equal here, this height. And it comes back and crosses again. And goes to negative infinity. So there is a minimum here and a max here. Here's a minimum and here's the maximum. Of course, I'm going to find the max and the min. If I find this one, I know this one. If this is, for example, at 1, 2, this has to be at negative 1, negative 2. I don't have to find both. Why? Because the function is odd. These have to be opposite. 1, 2, negative 1, negative 2. So with a graphing calculator, put in the function in y equals, clear, negative x to the fifth and minus x cubed, and then plus 6x. I don't know how high the maximum is. I don't know how low the minimum is. So I'm going to use the standard viewing window, but if they are not in the viewing window, I have to adjust. Okay, I'm going to use standard. Okay, so as expected, it's coming from positive infinity, crosses at negative 1.4, reaches a minimum, comes back up, crosses again the x-axis at the origin when x is 0, y is 0. It goes up to a maximum. As you see, these are exactly opposites. And then it crosses again the x-axis at 1.41 and goes to negative infinity. I want to determine this with a minimum. Second and calc, I want minimum, which is number 3. I want to tell the minimum, it's the calculator that the minimum is between negative 2 and 0. And 0, no, sorry. So minimum, between -2 and 0. Now give me the minimum. No, I don't want to guess. So the minimum is -0.91 and -4.1. So -0.91 and -4.1. Can anyone give us the maximum? So this point, -0.91, -4.1. Can anyone give us the maximum with no calculator? Knowing that the function is symmetric with respect to the origin. Is anyone with me? Anyone, please? Is anyone with me?
4.1.
I'm sorry?
Would be positive 4.1.
Yes, but what is the x? Yes. What is the x coordinate?
Positive 0.91.
Of course, absolutely. Makes sense. They have to be opposites. One in the first quadrant and the other one in the third. Excellent. Good. Let's go back. Thank you so much. Let's go back to the book and let's take a look at something like this. During a diagnostic evaluation, a 33-year-old woman experienced a panic attack. A few minutes after she had been asked to relax her whole body. The graph shows the rapid increase in her heart rate during the panic attack. So at minute 1, her heart rate is 66. Then it goes up gently. Then it comes down 8 minutes from the 7 minutes later, let's say. And then it shoots up and then comes down at minute 12. First question, for which time periods during the diagnostic evaluation was the woman's heart rate increasing? For which time it was increasing? And I'm going to write it here. So this is problem 75 on 382. Can anyone give us the interval of increasing? Between
8 and 10.
I agree, between 8 and 10, but also between 1 and 4. I agree, indeed, between 8 and 10, very clearly. From this point to this point, which means between 8 and 10, the function is increasing, but also between 1 and 4. Perfect. So 1, 4 with parentheses, union 8, 10. Perfect. Excellent. Part B. For which time periods during the diagnostic evaluation was the heart rate decreasing?
Is it decreasing from 4 to 8?
Perfect. And 4 to 8?
From 10 to 12?
Indeed. Very good. Here it is. From 4 to 8 is decreasing, but also from 10 to 12, the trend is decreasing. Excellent. How many turning points, which means max min, occurred for the woman's heart rate during the first 12 minutes? How many turns? From max to min, from max to min. How many max do you see? How many max do you see?
So if it went up twice, would that mean 2?
Yes, so 2 maxes. And what about its maxima? Sorry. And how many min?
Is it also 2?
I only see 1. Remember, the endpoints are not considered relative relative min or max. So 1, 2, 3. So we found 3 terms. The next, suppose that a polynomial function is used to model the data displayed. Use the number of turning points to determine the minimum degree of the polynomial function of best fit. If we found 3 terms, the minimum degree that the polynomial should have is, you can say 1500. Yeah, it's possible. But what is the minimum? If the function has 3 terms. What is the minimum degree that the polynomial should have if there are 3 terms?
4.
Indeed. Thank you so much. So remember what we said. If the degree, let's say for example, if the degree is 10, max number of turns is 10 minus 1. So if I have the degree of, if I have the maximum possible number of turns 9, then I know the minimum degree should be 10. Can it be 12? Yes. Can it be 20? Yes. But the minimum is 10, 1 more than the number of turning points. Very good. So if we found 3 turns, the maximum 3 turns, then the degree, minimum degree should be 4. Awesome. Okay. Next question. Should the leading coefficient be positive or negative? So here's the polynomial. Up, down, up, down. Again, up, down, up, down. Should the leading coefficient be positive or negative? So degree,
Positive.
yes. 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 So something like this has positive degree. Something like this, not degree, a positive leading coefficient. Because it has maximum, sorry, it's the opposite. And how do I know? I always compare to the quadratic function. This quadratic function has a maximum, so the leading coefficient is negative. This quadratic function has a minimum, so the leading coefficient is positive. The same way for degree 4. So it has to have a negative leading coefficient because otherwise it will not come from negative infinity and go back to negative infinity. The positive leading coefficient is like here. It comes from infinity and goes to positive infinity. Sorry about that. So it is negative. Good. So it's not this, but it's this. Always compare to the quadratic function. That's always the easiest. So you don't forget. Negative leading coefficient, it comes back to negative infinity. Positive leading coefficient goes back to positive infinity where it came from. Good. So again, leading coefficient has to be negative. Use the graph to estimate the woman's maximum heart rate during the first 12 minutes. So the maximum is right here. They want us to roughly estimate. So this is 110 and this is 120. So the distance is it's 90, right? So 90 roughly in the middle, 45. So I would say 110 plus 45, 154. So max 154. And use the graph to estimate the woman's minimum heart rate during the first. So the minimum is right here. Very strange. So this is a distance of 10. This is a distance of 90. I'm sorry. Oh, I'm sorry. I just misread this. So this is 110 to the 120. What am I doing? So so the distance is, so this is 5. So 115. Sorry. 115. What am I doing? So between 110 and 120, we have 10. So in the middle, roughly in the middle is 5. So that's 110 plus 5 is 115. Sorry. Okay, this one here, roughly between 60 and 70. Hard to read. If we say in the middle, maybe 65 or 66 as the minimum. So minimum, I don't know, 65, 66. The measurement unit, which is very important to always write, it's beats per minute. BPM, beats per minute. Is there anything else? No. So this was a typical example of information that we can read from a potentially 4th degree or maybe 6th degree, but at least minimum 4th degree function. We're able to identify increasing, decreasing. We're able to identify turning points. We are able to identify the minimum degree. And because it turns this way, always compare it to the quadratic function. So the leading coefficient has to be negative. And the maximum and the minimum were kind of hard to read. But we estimated 115, and we estimated somewhere between 65 and 66 beats per minute. Good, so let's go back. So this was not a 4th degree, was not a cubic degree. We looked at a 5th degree function, which is the same with a cubic function. Good. Anything else we'd like to continue with? So we looked at division of polynomials, so to speak. I mean, we can look at synthetic division. We looked at the long division. Let's choose the next topic.
Can we do a rational function?
Yes. Very good. What would you like? Type 1, type 2, slant asymptote? Very good. So that
Can
is
we
on.
go with the one with the slant asymptote?
Sure. You will not be asked to graph. We can graph it if you like, of course, for 29. I will not ask you to graph a function with a slant asymptote, but I will ask you to determine the slant asymptote, and I will ask you to graph type 1 or type 2. So let's choose.